Hi, this is Ryan, and this is my software presentation. I always like to start off by recapping what my capstone is. I'm basically building a predictive model in order to predict athlete performance, specifically wide receivers, expected receiving yards per game, depending on various attributes such as previous player statistics, opponent data, that sort of thing. When looking through and trying to figure out something that would apply to my specific project, I came across this Python library called LightGBM. LightGBM is a gradient boosting framework that was developed by Microsoft, and it's basically another type of tree-based learning algorithm. It's similar to Random Forest and XGBoost with some subtle differences that kind of differentiate itself from those types of models. So, how this model works and differentiates itself from other tree-based learning algorithms is basically all in the method it uses compared to other ones. So traditional tree methods will end up splitting at the root node and then growing the tree level by level, where it'll go down to one leaf, split that, and that same level, go to the other leaf, split that, and so on, in order to maintain a balanced tree structure. What the LightGBM method or model does is it actually grows the tree leafwise. So it'll end up splitting at the root on the leaf with the highest loss reduction. And as it goes down the tree, it'll continue to not split by the level, but split on the leaf with the highest loss reduction regardless of level. So even if we're continuing to split on the same leaf on the same branch, it'll keep going down if that has the highest loss reduction. This typically results in fewer trees needed because each iteration has more predictive power each run. Another interesting attribute of this model is its histogram-based splitting and how it processes continuous variables. With a typical tree, it'll usually measure all potential thresholds of a continuous variable. But instead, the LightGBM model ends up bitting these variables into histograms. So basically, given all the range of thresholds for a continuous variable, it'll end up bitting them equally into typically 255 different bins, where one bin could be from one threshold to another, and the next is picking up on that to the next threshold, and so on and so forth. This ends up reducing computation and memory use because instead of evaluating all potential thresholds that could be in the tens of thousands, it only has to evaluate the amount of bins, which is typically 255 for each feature. Some pros of the LightGBM model is that it has extremely fast training time. It can also handle both numerical and categorical variables, as well as accounts for potential missing data within your data set. And it's also able to achieve high accuracy and does well in predicting nonlinear relationships. Some cons of the LightGBM model are it is a risk of overfitting, as well as a large potential to have unbalanced trees, since it is just splitting on the leaves, not by balancing the tree out. As well as the parameters being extremely sensitive. So optimal parameters should be determined prior to training this model. Looking at my application and how it applies to my capstone and player prediction analysis, I realized that this model can handle the complex interactions between not just the player, but also the potential opponent they may be playing or other contexts, such as what team they're on or what's the weather, and is able to do this and predict these accurately. Another good thing about this model is it does a really well job at scaling across the potential seasons of my data set. Especially with sports, it is able to account for no future data leakage of data when training it. So you don't have any other statistics for a game that hasn't happened yet. Um, Lastly, it's very fast and effective given large data sets regarding player performance, and it does a good job when it has large tabular data, which in my case, with all the player statistics and potential other statistics, is the case. So, yeah, that is my software presentation.